Okay, we're going to find some equations of curves given some information. First one, we've got a curve that goes through -6, -3 and 1. And also that it goes through the y-axis at -36. And we're going to find the equation of this curve. Well, the root of 1 is generated by the bracket x minus 1, a root of -3 is generated by a bracket x plus 3, and the root of -6 is generated by a bracket x plus 6. I then need to put a proviso in front, which is k, to find the value of k. That's the style of this question. So I've then got another clue in the question, which is that I've been given another point, which is this one, 0 minus 36, where x equals 0 when y equals minus 36. So I can sub that in. When y equals minus 36, x is equal to 0. So I've got 0 minus 1 is -1, multiplied by 0 plus 3, so it's -1 times 3 is -3, -3 times 6 is -18. So now I've got -36 is equal to -18k, so k is equal to -36 divided by -18, and k is equal to 2. So can then sub that in, so y will be equal to 2 bracket x minus 1 bracket x plus 3 bracket x plus 6. That's 2 bracket x minus 1 bracket x squared plus 9x plus 18. And if I expand all that out, that'll give me 2x cubed plus 16x squared plus 18x minus 36. Next one, I'm given a curve like this, where we've got a point of equal roots at 3, and we also cut the x-axis at -2 and cut the y-axis at 9. So the bracket, which I'll get from a root of -2, will be x plus 2. And from 3, it will be x minus 3. But crucially, because it's a point of equal roots, so that is that it kisses the x-axis and goes back up rather than going right through. What I need to do is square that bracket, put my proviso of k in the front. I've also got another point that lies on the curve, which is the point 0, 9. So then, where I see y, replace it with 9, and where I see x, replace it with 0. So 9 is equal to k times, well, 0 plus 2 is 2, 0 minus 3 is -3, but square that and I get 9 times that by 2, and that's 18. So then k is equal to 9 over 18, which is 1/2. So then that's y equals 1/2 bracket x plus 2 bracket x minus 3 all squared. So that's 1/2 bracket x plus 2 bracket x squared minus 6x plus 9. And taking your time, that will be 1/2 bracket x cubed minus 6x squared plus 9x plus 2x squared minus 12x plus 18, close the bracket, open that up and collect together terms, will give me 1/2 x cubed minus 2x squared minus 3/2 x plus 9, final answer. We're now going to find the intersection of curves or a curve and a line. Okay, the first one, we're going to find the point, or points of intersection rather, of the straight line 4x minus 4, y equals 4x minus 4, and the parabola 2x squared minus 2x minus 12. So the first thing is that we're looking for points of intersection, so set y equal to y. So that will give me 2x squared minus 2x minus 12 is equal to 4x minus 4. Let's bring everything across, make it equal to 0. So that'll be 2x squared minus 4x comes across, that'll be minus 6x, minus 4 comes across, becomes plus 4. That'll be minus 8 is equal to 0. Okay, then I can then take out a common factor of 2, which will be 2 bracket x squared minus 3x minus 4 is equal to 0. I can then divide both sides by 2, and that'll give me x squared minus 3x minus 4 equals 0. Two numbers that multiply give minus 4, add together give minus 3. Will be x minus 4 bracket x plus 1 is equal to 0. That will then give me x minus 4 is equal to 0, x plus 1 is equal to 0, x equals 4, and x equals minus 1. Now it's looking for points of intersection, that's the x coordinates. To get the y coordinates, I then sub back into y. So I'll find one of the equations for y, which would be y equals 4x minus 4. So I'm going to sub both of these in. So first of all, sub x equals minus 1 into y equals 4x minus 4. That'll be y equals 4 lots of minus 1 minus 4. And that will be minus 4 minus 4, which is minus 8. So the first point of contact will be minus 1 minus 8. I'm then going to sub in my second x coordinate, which is x equals 4. So that will be y equals 4 lots of 4 minus 4. That's 8 minus 4, that's 16 minus 4 rather, which is 12. And the second point of contact then will be 4, 12. Okay, a second example. Find the coordinates of the points of intersection of the cubic y equals x cubed minus 9x squared plus 20x minus 10, and the line y equals minus 3x plus 5. So again, let's make y equal to y. So that will be x cubed minus 9x squared plus 20x minus 10 is equal to minus 3x plus 5. Let's bring it across, make it equal to 0. So that will be x cubed minus 9x squared. Minus 3x will come across, become plus 3x, that's plus 23x. Plus 5 across become minus 5. Minus 15 is equal to 0. This is now another case of looking for factors. So the factors of minus 15 are plus or minus 1, 3, 5 and 15. So let's try 1 to get going. So coefficients of 1, minus 9, 23 and minus 15. Drop the 1 down, multiply by 1 is 1. 1 minus 9 is minus 8, multiply by 1 is minus 8. 23 minus 8 is 15. Multiply by 1 is 15. And that will be 0. That will be a point of contact at x minus 1 is a bracket. The quotient here is x squared minus 8x plus 15. Two numbers that multiply together give 15, add together give minus 8, is going to be minus 5 and minus 3. That's then equal to 0. X minus 1 is 0, x minus 5 is 0, x minus 3 is 0. And that will give me 3 points of contact at x equals 1, x equals 5 and x equals 3. I can can then find the y coordinates by subbing these into y. So I'll just communicate that I'm going to do that. So I'm going to sub these into y equals minus 3x plus 5. So first one, minus 3 lots of 1 plus 5. It's minus 3 plus 5, that's 2. So the first point of contact then is 1, 2. I'm now going to sub in 3, so that will be minus 3 lots of 3 plus 5. That's minus 9 plus 5, which is minus 4. So second point of contact will be 3 minus 4. And the third one is minus 3 lots of 5 plus 5. So that's minus 15 plus 5, which is minus 10. So third point of contact is 5 minus 10. Okay, so let's try another one. Find the x coordinates of the points where the curves y equals 2x cubed minus 3x squared minus 10 and y equals 3x cubed minus 10x squared plus 7x plus 5 intersect. So I'll make y equal to y. Three x cubed minus 10x squared plus 7x plus 5 is equal to 2x cubed minus 3x squared minus 10. I'll then bring these across, change their sign, so it'll be 3x cubed minus 2x cubed is x cubed. Then minus 3x squared will come across and become plus 3x squared, so that's minus 7x squared. Plus 7x, minus 10 will come across and become plus 10, so that's plus 5 plus 10 is plus 15 is equal to 0. So we can now do some synthetic division, and again it's the plus or minus factors of 15, so let's try 1, see if that works. So 1 minus 7, 7 and 15, drop the 1 down, and that'll be 1 times 1 is 1. 1 minus 7 is minus 6, times that by 1 is minus 6 again. 7 minus 6 is 1, multiplied by 1 is 1, so that gives me 16. Didn't work, so this time I'll try minus 1. So 1 times minus 1 is minus 1, minus 1 minus 7 is minus 8, multiplied by minus 1 is 8, 8 plus 7 is 15, multiplied by minus 1 is minus 15, so this one did work. So then that comes from the bracket x plus 1, and the quotient out at the bottom is x squared minus 8x plus 15. Two numbers multiplied to give 15, add together give minus 8 is minus 3 and minus 5. So remember the question's looking for the x coordinates of the points of intersection. So then I've got x plus 1 is equal to 0, x minus 3 is equal to 0, x minus 5 is equal to 0. So that will be x equals minus 1, x equals 3, or x equals 5, final answer.